Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This channel with videos of practice problems is at smarturl.it/pass actuarial exams. Here you have 5 addresses, URLs of websites with information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, well, it's tax-deductible to the extent allowed by law. You can go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. Let x sub 1 in parentheses, x sub 2 and so on through x sub 6 be order statistics from a random sample of size 6 from a distribution with density function f sub x of x equal to 2x for x between 0 and 1 and 0 otherwise. What is e of x6? So what is the expected value of the 6th order statistic from this distribution? And we have 5 choices as always. And here's the solution. The cumulative distribution function of the original distribution is f sub x of x equal to integral from 0 to x of 2t dt, which is t squared evaluated from 0 to x, so it's x squared for x between 0 and 1. We also have f sub x of x equal to 0 for x less than or equal to 0, and 1 for x greater than or equal to 1. And therefore f sub x 6th of x, which is the probability that the 6th order statistic is less than or equal to x, well, that's equal to the probability that every single one of the 6 pieces of the random sample is less than or equal to x, and each such probability of being less than or equal to x for each of those pieces is f sub x of x, and there are 6 of them, then they're independent, so we multiply them out, and this becomes f sub x of x to the 6th, which is x to the 12th for x between 0 and 1. Also, f sub x of sub 6 of x is 0 for x less than or equal to 0, and it's 1 for x more than 1. Therefore, for x between 0 and 1, the survival function of the 6th order statistic is 1 minus x to the 12th, and it's 0 for x greater than or equal to 1, and of course this x sub 6, 6th order statistic random variable, is greater than or equal to 0 with probability 1. Therefore, we just apply the Darth-Vader rule to quickly find e of x to be the integral from 0 to 1 of 1 minus x to the 12th dx, the integral of a survival function, and that's equal to x minus x to the 13th over 13 evaluated from 0 to 1, and that's 12 over 13, which is answer E. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.